Okay, maggots, let's see how to do some arterial blood gas analysis. So remember, why arterial blood? Because that's the blood that's just been oxygenated on the way to the tissues. It's sort of like blood in its perfect form, okay? And who got that for you? The respiratory therapist. That's right. Always be nice to your respiratory therapist. You hear people say sometimes, well, the respiratory therapist will be going to get the blood sample. They say, no, I want the doctor to do it. No, you don't, you dumbass. The doctor they send in won't have done it in the last 6 months. The respiratory therapist did 5 of them this morning. Let the people who know how to do their jobs do their jobs. Don't tell them what to do. So what's going on here? We are going to look at blood gases in arterial blood in order to determine, first of all, whether the person is in a state of acidosis or alkalosis, and then secondly, basically who's causing the problem, and third, is the problem being compensated, which means is somebody trying to fix the problem. So what we do here is we have 3 things: pH, partial pressure of CO2, and the concentration of the bicarbonate ion. These are what we got from that blood sample, all right? So remember, your blood pH should be 7.35 to 7.45. What if it's too high? You are in a state of alkalosis. If it's too low, you are in a state of acidosis. All right? That's always the first thing you're going to do. When you get the numbers, that's numero uno. Get that, and then the rest will follow. So partial pressure of CO2, 35 to 45 millimeters of mercury. Remember the ridiculous way of measuring pressures in medicine goes back to the days when they had the sphygmomanometer with the big glass tube full of mercury, like this high off the floor. But that's just a way of measuring pressure, all right? And then the bicarbonate ion, 22 to 26 milliequivalents per liter. Remember, this is an ion. This is essentially a measure of electricity. Don't worry about the damn units so much. You do have to know these numbers, by the way. I will not give these to you on the exam. You must know these in your head, okay? Now, I'm going to show you what I think is a really easy way to do this. Now, you can go on the internet and find lots of other methods. For example, there's ROME, respiratory opposite metabolic equal. And I've had students before go, well, I think I'm going to use ROME. I say, help yourself, whatever you want. What I find, though, is sometimes the little tricks, when you're under stress on the exam, you remember, wait, respiratory opposite, what does that mean again? So, look, do it however you want to. I'm going to show you a way to do it that doesn't require on any memory tricks. It requires just on understanding what you're doing. I really think that's the way to do it. I think in the long run, you're better off. Memory will fail you. Understanding usually doesn't, okay? So, here's what we're going to do. We're going to look at the pH first, and then we can look at either one of these in any order. It doesn't matter. I have them written this next. I like to put this here because, look, 7.35 to 7.45, 35 to 45. See how easy that is? Okay, so, and then 22 to 26, I don't know. I don't have any trick for that. You just got to know it. So, I think maybe the best thing to do at this point is just to start in and do an example. So here we got one. We have a patient whose pH is 7.24. Their partial pressure of CO2 is 64 millimeters of mercury. Bicarb, 27 milliequivalents per liter. All right? So here's what we do. We always do this one first. It might be, by the way, that these values are normal. In which case, when we start, if the pH is normal, we're done. That's the easiest problem you can get. Nothing else to do. But let's take a look. pH of 7.24. So where does that fall here? That falls down here, doesn't it? So this person's in a state of acidosis. See, look, we're already a third of the way done. We just got started, we're a third of the way done. Now, partial pressure of CO2. Theirs is 64. So where does that fall? That falls up here, doesn't it? So we say that they are acidotic. Acidotic means that these values don't tell us whether the person is in acidosis or in alkalosis. It tells you which way this is trying to push things, okay? Or which way this one is leaning towards. So it doesn't really matter here. Acidotic is a typical term. Don't worry about it. Just acidotic. So then bicarbonate ion, 27. So where is that? That would be up here, all right? Remember, by the way, keep in mind what you're doing here. CO2, remember I've told you so many times how to think of CO2 in the body as acid. So notice what happens if CO2 is too high. You're in a state of acid, okay? And remember, the bicarb is the conjugate base of carbonic acid, so it's a base. So what happens if your bicarb is too high? That means you've got too much base. So not surprisingly, you're alkalotic. See, these things match up. They go with each other. So what happens now? We already figured out this person is in a state of acidosis. Let's go ahead and put that up there. This person is in a state of acidosis. All right. Now, what do we do next? Well, we need to know who's causing the acidosis. And it's going to turn out to be whichever one of these is in the same direction as this one was. So, in a state of acidosis, if the partial pressure of CO2 is acidotic, that means that this is what's causing the state of acidosis. Now remember, one last thing then here, before we go any further. This is a measure of what your respiratory system is doing. This is a measure of basically what your urinary system is doing. Remember the two organ systems that can control your acid-base balance? Respiratory and urinary, okay? So therefore, since it's the partial pressure of CO2 that is in the same direction as the acidosis or alkalosis, that means that the respiratory system is the cause. So this person is in a state of respiratory acidosis. Do you see how easy that was? In other words, their respiratory system is causing the acidosis, all right? Then, we look at whichever one isn't the cause. In this case, that's this one. We see that this is alkalotic. So what that means is, because it's higher than normal, what it means is that the kidney is trying to fix the problem for you. That's what's going on here. The kidney is pushing, it's like pulling bicarb back into the blood to try to balance out the acid state you're in. So what we say here is that you are in a state of respiratory acidosis and that it is compensated. Compensated means that the other system, whichever one wasn't causing the problem, is trying to solve the problem. Now really the term here should be partially compensated. I normally just write compensated if it's partially compensated. We'll see in a later example if it's actually fixing the problem, if the problem is actually fixed, temporarily at least, then we'll say it's fully compensated. So don't worry about that for right now. But do you see how this works? That's all we had to do. We looked at the pH first, then we looked at these two. Whichever one of these two is in the same direction as that, it's the cause of the problem. And the other one is going to tell us either whether the other system is trying to fix the problem or whether it's not. In this case, if instead of 27 it had been 24, that would mean that the kidney at this point is not really fixing the problem. And so what would we say? In that case we would say it was uncompensated, all right? So there's really nothing complicated about this. It's really very straightforward, all right? Shall we try one more example? Let's. So let's get rid of this. Use the rags from working on my truck. So here we got alkalosis. Here's acidosis. Alkalotic. Here we have acidotic. Acidotic, alkalotic. Okay. And let's use a different example here. So let's get rid of these numbers. Use the next set of numbers. Let's try a pH of 7.52, a partial pressure of CO2 of 41 millimeters of mercury, and a bicarb of 32 milliequivalents per liter. 32 milliequivalents per liter. All right, let's see one more time just how easy this is. Okay, so first of all, 752. Is this person in a state of acidosis or alkalosis? Yes, nice work there at home. This person is in a state of alkalosis. Let's look at the partial pressure of CO2 next, which is telling us about the respiratory component. We're at 41. Where are we? Oh my God, that's normal. So I'm just going to circle this to show that it's normal. Okay? 32, we're too high, so we're alkalotic. So let's look one more time. Then what does this tell us? Well, this person's in a state of alkalosis. Which one of these two matches that? Well, this one does, doesn't it? Therefore, remember this is the metabolic component. This person is in a state of metabolic alkalosis. All right? So this person's got a metabolic problem here. This might be somebody, a little kid, got into the drawer in Daddy's desk, ate 4 rolls of Tums. Ooh, wintergreen flavored. It's candy. So they're in a state of metabolic alkalosis. Here, the respiratory system is not currently doing anything to fix the problem. So what do we say? We say it is uncompensated. Okay? It's really that easy. So why don't you now try a few of these on your own? I gave you a list of practice problems. Try some of these practice problems on your own. I will come back and make another video. We'll do some more together, and I'll show you in that video an example of one that is fully compensated. Okay? So practice.